The cosmos is whispering its secrets, but are we listening? Across the vast darkness, strange events unfold that defy every law of physics we think we know. These are space anomalies, cosmic head-scratchers that leave even the brightest scientists utterly baffled. By the end of this journey, you will know the 25 greatest unsolved mysteries haunting our universe. We will encounter a bizarre interstellar object tumbling past our sun and investigate a star that dims in ways nothing natural should explain. What single cosmic puzzle leaves you the most curious about what is really out there? It came from the constellation Sagittarius, a burst of radio noise so powerful it defied all explanation. On August 15, 1977, the Big Ear radio telescope at Ohio State University recorded a signal that was both bizarre and brilliant. For 72 glorious seconds, it flooded the receiver, a narrowband radio wave that screamed of artificial origin, and then it vanished, never to be heard again. The signal was so extraordinary that the astronomer who discovered it, Jerry Amon, circled the computer printout data and simply wrote, "Wow, that single word gave this mystery its name." The data itself was coded as 6EQUJ5, a sequence representing the signal's incredible intensity. It was 30 times stronger than the background noise of deep space, a spike of pure, focused energy that seemed to shout into the void. The characteristics of this signal are what make it so compelling. It was a narrowband transmission, the exact kind we would expect from an intentional, technological source. Natural cosmic objects do not produce such clean, focused radio waves. This was the signature of something engineered. For decades, the leading theory was that we had finally intercepted a message from an alien civilization. It was the holy grail of the search for extraterrestrial intelligence, a 1-minute and 12-second long hope that we are not alone. Yet, all searches for a repeat signal have found nothing but silence. More recent explanations have tried to ground the mystery in natural phenomena. Some scientists suggested it could have been a reflection from a passing comet or a piece of human space debris. The problem is, comets were not in the right part of the sky that night, and the signal's properties do not neatly match any known natural event. The WOW signal stands as a perfect, frustrating cosmic tease. It was a whisper that felt like a shout, a single, perfect data point that proves we are listening, but leaves us wondering if anyone was ever truly there to speak. That solitary cosmic whisper was soon followed by a star that seemed to be blinking out. Far from the quiet radio telescopes on Earth, a star designated KIC 8462852, but better known as Tabby Star, began to behave in a way that no star ever should. Discovered by citizen scientists sifting through data from NASA's Kepler telescope, this star, located about 1,400 light-years away, displays a pattern of dimming that defies all logic. Unlike the predictable, gentle dip caused by an orbiting planet, Tabby Star experiences sudden, dramatic drops in brightness, sometimes by as much as 22%. This is not a subtle flicker. It is as if a colossal hand is periodically passing in front of the star, blocking its light in jagged, unpredictable, and deeply unnatural ways. The irregularity is the core of the mystery. A planet transiting its star creates a symmetrical, repeating pattern, like a precise cosmic clock. What we see with Tabby's star is chaos. The dips are steep, asymmetric, and they do not occur on a schedule. They can last for days or just for hours, with no clear pattern to their timing or their shape. This bizarre behavior immediately ignited the imagination of astronomers and the public alike. The most tantalizing, though speculative, explanation was the possibility of an alien megastructure. Imagine a vast swarm of energy collecting panels, a Dyson sphere under construction, orbiting the star and intermittently blocking its light. While a captivating thought, scientists have searched for any accompanying radio signals or other techno-signatures and have so far found none. More conventional theories have been proposed to explain the star's odd antics. A massive, fragmented comet swarm could be the culprit, with their dusty tails creating the irregular dimming. Or perhaps a cloud of interstellar dust is drifting between us and the star, warping our view. The problem is, each of these natural explanations struggles to account for the sheer scale and strangeness of the observed dimming, especially a historical dimming of the star's overall brightness over the past century. For years, telescopes around the world and in space have kept a vigilant watch on this stellar enigma, and while we have gathered more data, a definitive answer remains just out of reach. Tabby Star stands as a profound reminder that even the most familiar objects in our sky can hold shocking secrets, challenging our assumptions and daring us to find a new explanation for the impossible. The idea of a Dyson sphere transforms a cosmic curiosity into a profound question about intelligence in the universe. This concept, first proposed by physicist Freeman Dyson, is not a solid shell, but rather a vast swarm of orbiting collectors designed to capture a star's entire energy output. An advanced civilization, having exhausted the resources of its home planet, might construct such a megastructure to power its existence on an unimaginable scale. This is not just science fiction, it is a serious theoretical framework for how we might detect a civilization far older and more technologically mature than our own. The flickering of Tabby's star felt like a potential sighting, a shadow of something colossal moving into place, so how would we actually find one? A Dyson sphere would be invisible in visible light as it blocks the star it envelops. But according to the laws of physics, it cannot hide completely. All that captured stellar energy has to go somewhere. It would be re-radiated as waste heat, a massive, persistent infrared glow with no accompanying visible star to explain it. Astronomers have scanned the skies for these exact technosignatures, looking for objects that are dark to our eyes but blazing in infrared light. They have cataloged mysterious infrared sources, but in every case so far, a natural explanation has eventually emerged, like a surrounding cloud of warm dust or a distant galaxy. The frustrating truth is that the universe is filled with naturally occurring phenomena that can mimic the signs of an alien engineering project. Despite decades of searching and the tantalizing clues from stars like Tabby's, no object has yet provided the definitive, simultaneous combination of extreme dimming and an inexplicable infrared signature that would point conclusively to intelligence. This leaves us in a fascinating position, forever on the edge of a discovery that would redefine our place in the cosmos, yet always confronted by nature's own talent for building wonders that rival our wildest imaginings. While we search for distant megastructures, a visitor from another star system slipped right through our cosmic backyard. In October 2017, astronomers in Hawaii spotted an object moving at breathtaking speed, an object that did not belong to our sun. They named it Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. This was the first confirmed interstellar object ever detected, a traveler from a star system far beyond our own. Its arrival was a monumental event, but its bizarre properties are what truly shattered expectations. First, there was its shape. Based on the way its brightness fluctuated, scientists deduced Oumuamua was not a round lump of rock. It was profoundly elongated, shaped like a cigar or a pancake, with dimensions estimated to be up to 10 times longer than it was wide. This was unlike any asteroid or comet we had ever seen in our own solar system. Natural objects tend to be roughly spherical or lumpy, not this impossibly slender needle tumbling through the void. Then came the real mystery, its movement. As Oumuamua sped away from the sun, It did something impossible for a simple rock. It accelerated. This non-gravitational acceleration could not be explained by the pull of the sun's gravity alone. A normal comet exhibits this kind of behavior because as it heats up, it vents gas and dust from its surface, creating a visible coma and tail that act like a natural rocket engine. Yet when astronomers pointed their most powerful telescopes at Oumuamua, they saw nothing. No surrounding cloud of gas, no dusty tail, no coma whatsoever. It was completely dark and inert, a silent, speeding shape with an invisible engine. This complete lack of outgassing left scientists with a profound puzzle. What force was pushing this object along? The scientific debate ignited, spanning from the conventional to the extraordinary. Some proposed it could be a cosmic dust bunny, a fragile aggregate of material with such low density that sunlight itself could be pushing it like a light sail. This idea, while natural, was unprecedented. Others, most notably Harvard astronomer Avi Loeb, put forward a more provocative hypothesis. He suggested Oumuamua could be artificial in origin, a piece of advanced technology from an alien civilization, perhaps a discarded light sail drifting between the stars. The mainstream astronomy community largely favors natural explanations, pointing out that we have only just begun to observe interstellar objects, and our expectations are based on a sample of one. But every natural model struggles to fully explain the complete set of Oumuamua's oddities, its strange shape, its sudden acceleration, and its utter lack of a visible cometary tail. By the time we knew enough to look more closely, it was already too far away, a fleeting ghost in the cosmic night. Oumuamua left our solar system as mysteriously as it arrived, a silent scout that challenged our understanding of the universe and left us with a single, haunting question. What else is passing through the darkness that we have not yet learned to see? That invisible push remains the central puzzle of Oumuamua. When a simple rock flies by the sun, gravity dictates its path with unbreakable rules. Oumuamua broke those rules, accelerating as it departed in a way that demanded a physical force was at work. The most obvious suspect is outgassing, the same process that drives a comet. As a comet's icy surface heats up, it erupts, venting gas and dust into space. This acts like a natural rocket thruster, nudging the object along, but for this to work, there must be a visible signature, a cloud of material around the comet called a coma, and often a magnificent tail streaming away from the sun. Every telescope trained on Oumuamua searched for this evidence and found absolutely nothing. It was starkly, impossibly bare. A comet accelerating without any cometary activity is like a car speeding up with its engine turned off and no exhaust coming from the tailpipe. It simply should not happen. This glaring contradiction forced scientists to invent entirely new categories of explanation. One compelling idea proposed that Oumuamua was not a rocky asteroid at all, but a hydrogen iceberg. In the coldest depths of interstellar space, a chunk of solid hydrogen could form. As it neared our sun, the heat would cause the frozen hydrogen to sublimate, turning directly from a solid into a gas. This invisible outgassing could provide the necessary thrust without producing any dusty debris for our telescopes to see. The theory is elegant, but it comes with its own immense challenges. A hydrogen iceberg would be incredibly fragile, likely evaporating entirely on its long journey between stars. Could such a fleeting object really survive long enough to reach us? Another natural explanation points to the power of light itself. Radiation pressure from sunlight can push on very thin, lightweight objects. This is the principle behind a solar sail. Perhaps Oumuamua was an extraordinarily old, porous comet, or a fractal-like collection of cosmic dust so lightweight and thin that photons from the sun were enough to give it a gentle, continuous push. This would explain the acceleration without requiring any outgassing at all. Yet, we have never seen a natural object so susceptible to light pressure in our own solar system. Oumuamua, a single, silent traveler, has fundamentally challenged our catalog of what is possible. It forced astronomers to confront the limits of their knowledge and to seriously consider that the population of small bodies drifting between stars is far more diverse and strange than we ever dreamed. Oumuamua's silent passage forces us to confront a much larger, more profound silence. The universe is impossibly old and unimaginably vast, filled with billions of planets that seem perfectly suited for life. Given these numbers, the cosmos should be teeming with civilizations, its background hum a cacophony of alien conversations, yet when we listen, all we hear is an eerie, unbroken quiet. This contradiction is the Fermi Paradox, a cosmic anomaly of pure absence that is every bit as puzzling as a strange signal or a flickering star. Physicist Enrico Fermi famously captured this dilemma with a simple, devastating question. Where is everybody? The mathematics are overwhelmingly on the side of life. There are more stars in the universe than grains of sand on every beach on Earth. A significant fraction of those stars have planets orbiting within their habitable zones, the so-called Goldilocks region where temperatures are just right for liquid water, the essential ingredient for life as we know it. With so many opportunities, and with the universe being 13.8 billion years old, it seems statistically inevitable that intelligent life would have arisen many times over, and that at least some of those civilizations would have expanded across the galaxy. The Milky Way alone is old enough for this to have happened many times, leaving behind artifacts, signals, or even entire re-engineered stars, and yet we see nothing, we hear nothing. The silence is deafening. This glaring absence has spawned a host of possible solutions, each more thought-provoking than the last. One of the most sobering is the concept of the Great Filter. This theory suggests that there is some kind of barrier, an evolutionary or technological challenge so difficult that almost no civilization can overcome it. The filter could lie in our past, meaning that the emergence of intelligent life itself is a fantastically rare fluke, and we are simply the lucky ones. Or, more ominously, it could lie in our future. Perhaps every advanced civilization eventually discovers a technology, like artificial intelligence or self-replicating nanobots, that inevitably leads to its own destruction. In this scenario, the silence is the sound of countless civilizations reaching a certain point and then vanishing. Another fascinating idea is the zoo hypothesis. Imagine our solar system as a protected wilderness area, a nature preserve set aside by a vastly more advanced galactic community. They are fully aware of us, but they have chosen a strict policy of non-interference, observing us from a distance until we reach a certain level of maturity. We would not see or hear them for the same reason animals in a zoo do not perceive the visitors watching from behind the one-way glass. Then there is the simplest and perhaps most lonely explanation. Space is just too big. The distances between stars are so immense that even if the galaxy is full of life, the sheer scale makes communication or travel practically impossible. An alien civilization might have flourished and died out millions of years ago on the other side of the Milky Way, their light and signals only now reaching an Earth that was still dominated by dinosaurs. We are like isolated islands in an ocean too vast to cross, each one unaware that the others even exist. This paradox holds up a mirror to our own civilization, forcing us to wonder if our current silence is a temporary phase or a permanent condition. Are we the first to reach this point? Are we the last? Or are we simply not listening in the right way? The answer, for now, remains hidden in the quiet between the stars. The profound silence of the cosmos hints at a deeper mystery, one woven into the very fabric of space itself. The universe is held together by a ghost, an invisible substance whose presence we can only feel through its immense gravitational pull. This is dark matter, the ultimate cosmic anomaly. It makes up roughly 27% of everything that exists, nearly 6 times more than all the atoms, stars, and planets we can see combined. Yet, for over 80 years, it has completely evaded every attempt at direct detection. We know it is there because without its gravitational glue, our universe would simply fly apart. The first compelling clue came from the way galaxies spin, when astronomers measured the rotation speeds of stars within spiral galaxies. They made a startling discovery. According to the laws of gravity, stars on the outer edges of a galaxy, far from the bright central mass, should be moving much more slowly, just as Pluto orbits our Sun more sluggishly than Mercury. But that is not what happens. Stars on the galactic fringe whip around at nearly the same high speed as those near the center. It is as if the entire galaxy is embedded within an enormous, invisible sphere of mass, a halo of something we cannot see, whose gravity is the only thing preventing these stars from being flung off into the void. This missing mass, this ghostly anchor, is dark matter. Another dramatic piece of evidence comes from a phenomenon called gravitational lensing. Albert Einstein predicted that a massive object warps the fabric of space-time, bending the path of light that travels past it like a lens. When astronomers look at massive galaxy clusters, they see distant galaxies behind them distorted into faint, shimmering arcs. The amount of bending is so extreme that the visible matter in the cluster is not nearly enough to account for it. There must be a tremendous amount of unseen mass, a hidden gravitational landscape of dark matter contorting the light from those background galaxies. We are literally seeing the shadow of the invisible, so what could this elusive substance possibly be? The hunt for a candidate has led physicists to propose some truly exotic particles. The leading contender for decades has been WIMP, or weakly interacting massive particles. These are theoretical heavy particles that do not interact with light or ordinary matter except through gravity and perhaps the weak nuclear force. They would be streaming through this room, through you right now by the billions, utterly unnoticed. Vast experiments deep underground, shielded from cosmic rays, have been searching for the faintest bump of a WIMP collision for years, so far without success. Another promising candidate is the Action, a particle that is fantastically light but could exist in such staggering numbers that it accounts for the universe's missing mass. Actions were originally proposed to solve a different problem in particle physics, but they possess the perfect qualities for dark matter, barely interacting with the familiar world. Then there is the possibility that we have gravity all wrong, and that our theory of gravity itself needs a fundamental rewrite on cosmic scales, a modification that would make dark matter unnecessary. Yet the evidence from colliding galaxy clusters, where dark matter and normal matter can be seen separating from one another, strongly suggests that dark matter is a real, physical substance. It is not a flaw in our equations, it is a component of the universe we have not yet learned to touch. This ghost in the cosmic machine remains one of the most profound and embarrassing problems in all of physics. We have mapped its gravitational influence across the largest structures in the universe. We know it dictates the fate of galaxies, and yet we have no idea what it is. It is the silent, invisible partner to everything we see, a reminder that most of the universe is made of something we do not understand. But if dark matter is the ghostly anchor holding the cosmos together, its counterpart is a phantom force tearing it apart. Dark energy is the ultimate cosmic rebel, a mysterious form of energy woven into the fabric of empty space itself, and it possesses a gravity that is not attractive, but repulsive. This is the force that is causing the expansion of our universe to accelerate, sending galaxies flying away from each other at an ever-increasing speed. The discovery of dark energy was a shock that overturned a fundamental assumption in cosmology. For decades, astronomers believed that the gravitational pull of all the matter in the universe, both seen and unseen, would eventually slow down the expansion that began with the Big Bang. The great question was whether that slowdown would lead to a big crunch or just a gradual coasting. Then, in the late 1990s, two independent teams of scientists were observing distant stellar explosions known as Type 1, a supernova. These supernovae act as standard candles, their known intrinsic brightness allowing astronomers to calculate their precise distance by measuring how much the light from these explosions was stretched or redshifted. They could also determine how fast the universe was expanding when that light was emitted billions of years ago. The data revealed something astonishing. The distant supernovae were fainter than they should have been, meaning they were farther away than expected. The only explanation was that the expansion of the universe was not slowing down at all, it was speeding up. Something was actively pushing galaxies apart, and that something was dubbed dark energy. This revolutionary finding was later confirmed by other lines of evidence, most notably the detailed map of the cosmic microwave background, the faint afterglow of the Big Bang. This ancient light reveals the infant universe's composition, and it shows that dark energy makes up a staggering 68% of the total mass energy of the cosmos. Dark matter comprises 27%, and everything we can actually see, all the stars, planets, and galaxies, amounts to a mere 5%. We are living in a universe dominated by forces and substances we cannot see or directly interact with, so what could dark energy possibly be? The leading and simplest explanation is the cosmological constant, an idea that Albert Einstein originally proposed and then later called his greatest blunder. It represents a constant energy density inherent to the vacuum of space itself. Even in what we consider complete emptiness, quantum fields are constantly flickering, creating a background energy that produces a repulsive gravitational effect. The problem is, when physicists try to calculate the strength of this vacuum energy using quantum mechanics, the predicted value is astronomically, impossibly large, 120 orders of magnitude stronger than what we observe. This is the worst prediction in the history of physics. Another theory suggests dark energy is not a constant at all, but a dynamic force field that has changed over time. This concept, known as quintessence, posits a new, fifth fundamental force that could gradually weaken or strengthen, altering the ultimate fate of the universe. Whether it is a constant or a shifting field, dark energy presents a fundamental challenge to our understanding of physics. It tells us that the vacuum of space is not nothing. It is a dynamic, energetic entity whose properties are writing the final chapter of the cosmos, a chapter where galaxies beyond our own local group will eventually accelerate away over a cosmological horizon, disappearing from our view forever. This mysterious pressure in the void is the dominant force in our universe, and we have no real idea what it is. While dark energy pushes the universe apart on the grandest scales, a more local but equally powerful force is pulling us in. Our Milky Way galaxy is not drifting aimlessly, it is racing through the cosmos at a breathtaking speed of over 1 million miles per hour, drawn towards a specific point in the void known as the Great Attractor. This colossal gravitational anomaly, located in the general direction of the Centaurus and Norma constellations, is not just tugging on us, but on thousands of other galaxies in a vast river of stars, all flowing toward the same unseen destination. The sheer power required to orchestrate this cosmic migration is almost incomprehensible, a gravitational force so immense it can dictate the motion of entire galaxies. Yet, for decades, the true nature of the Great Attractor remained one of astronomy's most frustrating blind spots. It lies directly behind the plane of our own Milky Way, a region astronomers call the zone of avoidance. This is the thick, dusty, and starlit central disk of our galaxy, which acts like a cosmic curtain, obscuring our view of the universe beyond invisible light. Trying to see the Great Attractor from Earth is like trying to spot a distant lighthouse through a dense, blinding fog. We could feel its immense pull, but we could not see what was doing the pulling. What could possibly possess such gravitational authority? Initial theories suggested it was an exceptionally massive concentration of galaxies, a supercluster of unprecedented scale. The pursuit to see behind the curtain drove astronomers to use other tools, peering through the dust with X-ray and radio telescopes that can penetrate the obscuring veil. These observations revealed that the Great Attractor is indeed part of a colossal structure, now identified as the Laniakea supercluster, of which our own Milky Way is just a tiny suburb. Laniakea, a Hawaiian word meaning immense heaven, is a filamentary web of hundreds of thousands of galaxies, all bound together by gravity and flowing towards a central gravitational point, the Great Attractor. But here is the twist: the Great Attractor itself may not be the final destination. The entire Laniakea supercluster, including the Great Attractor, appears to be part of an even larger and faster flow, pulled towards something else far more massive and distant, known as the Shapley Attractor. This reveals a universe of nested hierarchies where we are drawn to a local center of gravity, which is itself drawn to a more powerful one in an endless cosmic dance. The mystery has evolved from simply identifying the Great Attractor to understanding its role in this vast, intergalactic current. Is it a stable, permanent structure or a temporary knot in the cosmic web? Its discovery fundamentally changed our perspective, showing us that even the grandest structures we can see are merely passengers caught in the irresistible pull of something hidden just out of sight. While we are pulled by the immense gravity of the Great Attractor, another region of the cosmos exerts its own strange influence through sheer, staggering absence. The Boötes Void is a spherical chasm of near nothingness so vast it could swallow thousands of galaxies like our own, stretching an almost incomprehensible 330 million light-years across. This region of space holds so few galaxies that astronomers have nicknamed it the Great Nothing. Its emptiness is not just a curiosity, it is a profound challenge to our understanding of how the universe organizes itself. According to our best models, matter in the universe should be distributed in a vast cosmic web with dense filaments of galaxy clusters surrounding bubble-like voids. But the Boötes Void is not a bubble, it is a cavern of unbelievable proportions. If our Milky Way were at its center, we would not have known other galaxies existed until the 1960s. The sheer scale of this emptiness defies probability, leaving cosmologists to wonder how such a barren desert could form in a universe supposedly filled with structure. Within this colossal void, astronomers have identified only about 60 galaxies, a number that should be in the tens of thousands. These lonely star systems are the sole inhabitants of this cosmic ghost town, isolated islands of light adrift in an ocean of darkness. Their very existence deepens the mystery as they huddle together in a thin, thread-like filament that stretches across the void. This suggests that even in the greatest of emptiness, the faint whisper of the cosmic web can still be felt, guiding the little matter that remains into fragile, linear structures. How could such a void have come to be? One leading theory points back to the very first moments of the universe. Microscopic quantum fluctuations in the dense energy of the Big Bang are thought to have been stretched to cosmic proportions during a period of rapid inflation, seeding the initial irregularities that would later grow into galaxies and voids. Perhaps the Boötes Void is simply an extreme example of this, a single, gigantic underdensity that has been expanding and emptying out for billions of years. Another, more speculative idea involves cosmic inflation occurring at different rates in different regions. potentially creating vast, empty pockets as bubbles in a foamy multiverse. The haunting presence of the Boötes Void forces us to confront the limits of our cosmic maps. Is it a unique monster, a statistical fluke on a scale we can barely grasp, or is it a sign that our theories of the large-scale structure of the universe are still missing a crucial piece of the puzzle? It stands as a monument to absence, a silent, spherical reminder that the cosmos is capable of creating emptiness on a scale that dwarfs our imagination. Deep in the cold, dark expanse beyond Neptune, two human-made objects were subtly breaking the rules. The Pioneer 10 and 11 spacecraft, having completed their grand tours of the outer planets, were now on a perpetual journey into interstellar space. But as scientists tracked their trajectories over decades, they noticed something deeply puzzling. Both spacecraft were experiencing a tiny, unexplained deceleration, a constant, faint pull back toward the Sun. This was the Pioneer anomaly, a deviation so small it amounted to less than a billionth of the gravity we feel on Earth, yet it persisted for years, defying every calculation. For a long time, this minuscule drag was a major headache for physicists. It seemed to suggest a fundamental flaw in our understanding of gravity itself. Perhaps Einstein's theory of general relativity needed a slight tweak at the vast scales of the solar system, or maybe it was evidence of unseen, diffuse dark matter exerting a gravitational tug. The anomaly became a classic scientific mystery, a quiet whisper that something in our cosmic model might be profoundly wrong. The investigation was a masterclass in patience, requiring scientists to recover decades-old data and account for every conceivable physical effect on the distant probes. The ultimate solution, however, was not a rewrite of physics, but a triumph of meticulous engineering. The primary culprit was found to be heat. The spacecraft's nuclear power sources generated a steady trickle of warmth, which was radiated away into space. Crucially, this radiation was not perfectly even. More heat was emitted from the back of the spacecraft than from the front. This anisotropic, or directionally lopsided, radiation acted like a tiny, continuous rocket thruster pushing gently backward, creating the illusion of a slight solar pull. It was a subtle thermal effect that had been overlooked for years. While this explanation accounted for the vast majority of the anomalous drift, a fascinating sliver of the puzzle remains. Some analyses suggest that after all known effects, including the heat radiation, are perfectly accounted for, a tiny residual acceleration might still be unaccounted for. This leftover whisper is so small it might yet be an unmodeled detail, a final quirk of the spacecraft's complex design. The story of the Pioneer anomaly serves as a humbling lesson. It reminds us that the path to solving a cosmic mystery is often one of painstaking detail, of chasing down every last photon of heat before we can declare a law of physics broken. It is a testament to the fact that sometimes the universe's greatest secrets are hidden not in the grand and dramatic, but in the whisper-quiet details we almost failed to hear. Just as the Pioneer probes revealed secrets hidden in the quietest of details, the cosmos can also scream in a burst of raw power. Fast radio bursts are exactly that, cosmic screams of unknown origin. These are not gentle whispers of radio static, but intense, millisecond-long flashes of radio waves that travel across billions of light-years, carrying more energy in a single blink than our Sun releases in 80 years. They appear without warning, a brilliant spike of energy on a radio telescope's data, and then they vanish, often never to be seen again. Their fleeting nature is what makes them so incredibly difficult to catch and study. You have to be looking at exactly the right patch of sky at exactly the right millisecond, a cosmic lottery that makes each detection a precious event. For years, these one-off bursts were the ultimate astronomical enigma, appearing random and utterly unpredictable, but then something changed. Astronomers discovered a source known as FRB 121102. Unlike its cousins, this one did not just fire once and go silent. It repeats. It crackles back to life again and again, sending out bursts from the same location in a distant dwarf galaxy. This repeater was a game changer, a vital clue that finally gave scientists a fixed address to investigate. So what cosmic engine could possibly produce such a violent, fleeting, and yet sometimes repetitive signal? The leading natural explanation points to the most magnetic objects in the universe, magnetars. These are a special type of neutron star, the collapsed core of a giant star, with a magnetic field so powerful it could erase a credit card from half the distance to the moon. A starquake on the surface of a magnetar, a sudden fracturing of its rigid crust, could unleash a catastrophic release of magnetic energy, a shockwave that ripples out into space as a brilliant flash of radio waves. This model fits the incredible power and brief duration of the bursts perfectly. Other theories suggest even more cataclysmic events, like the collision of two black holes or the violent merger of a neutron star with a black hole. These events could, in theory, release a final, concentrated shriek of energy across the radio spectrum. And then there is the more speculative, but undeniably captivating, possibility. Could these focused, energetic pulses be evidence of advanced alien technology? Some scientists have proposed that a sufficiently advanced civilization might use a powerful beam of energy, perhaps to propel enormous light sails on interstellar ships. If such a beam were to randomly sweep across our line of sight, we would see it as an incredibly bright, incredibly brief flash, much like a lighthouse beam momentarily blinding a distant observer. While this is not the favored explanation, its continued discussion highlights just how baffling these signals truly are. The central challenge remains their speed. A burst that lasts only 1,000th of a second leaves no time for follow-up. By the time other telescopes can swivel to look, the show is long over. This forces astronomers to rely on vast radio telescope arrays, like the CHIME instrument in Canada, which constantly scans huge portions of the sky, acting as a giant cosmic net, hoping to catch these fleeting, energetic ghosts. Each new detection, especially from a known repeater, adds another piece to the puzzle, slowly revealing the nature of these mysterious cosmic explosions that shout into the dark for the briefest of moments. These fleeting cosmic shouts are not the only signs of a universe in motion. Far beyond the pull of the great attractor, at the very edge of everything we can possibly see, astronomers have detected something even more unsettling. Entire clusters of galaxies are streaming in a coordinated rush, as if pulled by a force from outside our universe. This is the dark flow, a controversial and profound mystery that challenges our most basic understanding of the cosmos. The discovery came from analyzing the cosmic microwave background, the ancient afterglow of the Big Bang that permeates all of space. Scientists used a subtle phenomenon called the kinetic Sunyaev-Zeldovich effect. As this primordial light travels through the hot gas of a galaxy cluster, the cluster's motion imprints a tiny, telltale shift on the light's temperature. It is like seeing the wake of a ship moving through a calm sea. By meticulously measuring this effect for over 1,000 distant clusters, researchers found a startling pattern. These colossal structures, separated by billions of light years, were all moving in the same direction at incredible speeds, over 1,000 miles per second. This motion is not part of the universe's general expansion. That expansion carries galaxies apart like raisins in a rising loaf of bread. The dark flow is different. It is a coordinated drift, a current flowing through the cosmic loaf itself, the known distribution of matter in our universe, including all the dark matter and the pull of the great attractor, cannot account for this movement. The gravity from everything we see and everything we infer is simply not strong enough or organized enough to create this coherent stream, so what could possibly be pulling millions of galaxy clusters in a single direction? The most mind-bending possibility is that the dark flow is evidence of something beyond our cosmic horizon. Our observable universe is a bubble limited by the distance light has had time to travel since the Big Bang. But the entire cosmos is likely much, much larger, perhaps infinite. The theory of cosmic inflation suggests that our universe is just one patch in a vast multiverse. If another of these cosmic patches, another universe, existed extremely close to our own in the first moment of inflation, its gravitational influence could have reached across the nascent void. Even though that other universe is now forever beyond our sight, its immense gravity could still be tugging on the matter at the very edge of our own, creating the ghostly current we detect as the dark flow. It is a staggering thought that we might be feeling the gravitational breath of another cosmos. Of course, the scientific community remains deeply divided. The detection itself is at the absolute limit of our measurement capabilities, and some analyses have failed to confirm the signal, attributing it to statistical noise or unaccounted for systematic errors. The debate is fierce precisely because the stakes are so high. If the dark flow is real, it does not just add a new object to our celestial maps, it redraws the map itself, suggesting that our universe is not a self-contained island, but part of a far grander and utterly invisible structure. It forces us to ask if the greatest anomalies are not within our universe, but are signs of what lies beyond its walls. Our own moon holds a mystery as old as the telescope itself. For centuries, astronomers gazing at its tranquil face have witnessed impossible things, fleeting flashes of light, patches of landscape that momentarily glow or dim, and strange, shifting obscurations that appear and vanish in minutes. These are transient lunar phenomena, or TLP, ghostly events that paint the dead moon with a flicker of unexplained life. The records are extensive and credible. In 1787, the renowned astronomer William Herschel, the man who discovered the planet Uranus, observed 3 glowing red spots on the dark part of the moon. He was so convinced he was seeing volcanic eruptions that he even attempted to inform King George III. In the 1960s, astronomers at the Lowell Observatory documented a series of bright, pink flashes in the colossal crater Alphonsus. These are not just ancient anecdotes, either. Modern amateur astronomers with sophisticated equipment regularly report these brief, enigmatic flashes, particularly around specific regions like the crater Aristarchus. The challenge has always been their fleeting nature. A glow may last for 20 minutes, a flash for a single second. By the time you call another observer to confirm it, the event is over, leaving only a personal log entry as evidence. This transient quality has made TLP one of the most frustrating and controversial subjects in astronomy. So, what could possibly be causing these lunar hiccups? One of the leading natural explanations is outgassing. The moon is not entirely geologically dead, and it is thought that pockets of radioactive elements deep below the surface could occasionally heat up, causing trapped gases like radon to escape. When this gas vents into the vacuum of space, it could kick up fine, highly reflective dust that would catch the sunlight, creating a temporary, hazy glow or an obscuration that slowly fades as the dust settles. Another common theory points to meteoroid impacts. The moon has no atmosphere to burn up incoming space rocks, so even small pebbles strike the surface at tremendous speeds. These impacts vaporize rock on contact, creating a brief, intense flash of light and a temporary hot crater. Our own lunar orbiters have actually confirmed this, recording hundreds of such impact flashes during meteor showers. Then there is a more subtle possibility: electrostatic phenomena. The lunar surface, bathed in the sun's ultraviolet radiation, can build up significant static electricity. Some scientists theorize that this static charge could suddenly discharge, like a massive spark, or cause layers of light dust to levitate, creating a temporary, shimmering cloud that alters the reflectivity of a small area. Yet, even with these plausible explanations, a perfect fit remains elusive. Some observed events, like the large, colored glows, do not perfectly match the profile of a simple impact or a small gas release. Despite having probes in orbit around the Moon, capturing its surface in exquisite detail, these phenomena are so brief and localized that our spacecraft are rarely looking at the right place at the right time. The Moon, our constant celestial companion, still whispers to us with these fleeting, ghostly lights, a persistent puzzle that reminds us that even the most familiar world can hide secrets waiting in the shadows. Far from the silent, airless Moon, a giant world displays a geometric wonder of its own. At Saturn's North Pole, a storm rages that is unlike any other in our solar system, a perfect, colossal hexagon. This six-sided jet stream, with sides longer than the diameter of our entire planet, has been churning for decades, a majestic and impossible puzzle etched into the clouds. It was first glimpsed by the Voyager probes in the 1980s and later studied in breathtaking detail by the Cassini spacecraft, which confirmed this was not a fleeting illusion but a permanent, stable feature of Saturn's atmosphere. The sheer scale is difficult to grasp. A honeycomb cell large enough to swallow 2 Earths with room to spare, spinning at the planet's crown. The existence of such a sharp, geometric shape in a gaseous atmosphere defies everything we know about fluid dynamics. On Earth, spinning systems in fluids, from water going down a drain to massive hurricanes, naturally form circular vortices. The physics favors curves, not corners. A stable hexagon on this scale should not exist. It is a cosmic violation of the rules. Scientists have worked tirelessly to solve this puzzle in the lab. By placing a cylinder of fluid on a spinning table, they can simulate the conditions of a polar atmosphere. Remarkably, when the inner part of the cylinder is spun at a different speed than the outer part, sharp, polygonal shapes do emerge in the fluid between them, including a distinct hexagon. This suggests that Saturn's hexagon is a kind of standing wave pattern, a stable oscillation created by differences in wind speed at various latitudes. Think of it as a gigantic, self-reinforcing atmospheric ripple, where the physics of the spinning planet locks the wave into a precise six-sided form. Yet the laboratory models, while fascinating, are not a perfect match. They cannot fully replicate the immense scale, the complex chemistry, or the deep atmospheric forces at work on Saturn. The fundamental question remains: why a hexagon? Why not a pentagon or an octagon? What specific conditions on Saturn so perfectly favor this number 6? And how has it maintained its razor-sharp definition for so long against the chaotic forces that should blur its edges? The Cassini spacecraft provided years of data, watching the hexagon change with Saturn's seasons, but it left without delivering a final answer. This planetary marvel continues to spin in the distant dark, a beautiful, geometric whisper from a gas giant, reminding us that even the most basic laws of nature can still produce wonders we do not fully understand. The perfect hexagon of Saturn is a stable, geometric marvel, but the death of a star is a chaotic, explosive event that should be impossible to miss. Yet one of the youngest and most studied supernova remnants in our galaxy has a ghost in its story. Cassiopeia is a sprawling, beautiful wreckage of a star that exploded approximately 350 years ago, based on the expansion of its debris cloud, which now stretches over 10 light-years across. astronomers can pinpoint the time of the cataclysm to around the year 1670. This places it squarely within the era of modern astronomy, a time when sky watchers across Europe and Asia were meticulously documenting the heavens. A stellar explosion of this magnitude, so relatively close to Earth at just 11,000 light-years away, should have been a brilliant new star in the sky, visible even in broad daylight for weeks. It would have been one of the most spectacular celestial events in human history, but when scientists scour the astronomical records from that period, they find nothing. No chronicler, no astronomer, no court astrologer made a note of a new star appearing in the constellation Cassiopeia. The star died, and not a single person on Earth seems to have seen it happen. This is the core of the mystery, a cosmic crime scene with a missing victim and no witnesses to the event itself. So what could explain this profound silence? One possibility is that the supernova was an unusual type, known as a type IX. This is a faint supernova, a sort of fizzled-out explosion that fails to completely unbind the star. Instead of a titanic blast that outshines a galaxy, it produces a much dimmer flash, perhaps only 1% the brightness of a normal supernova. If Cassiopeia A was the product of such a weak explosion, it might have simply been too faint to be noticed by the naked eye observers of the 17th century, lost in the glow of the Milky Way. Another compelling theory points to an interstellar dust cloud. The space between stars is not perfectly empty, it is filled with tenuous clouds of cosmic soot. If a thick veil of this dust lay directly between the supernova and Earth, it could have dramatically dimmed the light of the explosion, filtering out its brilliance before it ever reached our planet. We would see the glowing, heated dust around the remnant today, which we do, but the initial flash could have been muffled into obscurity. The search for the progenitor star has turned into an exercise in cosmic forensics. By studying the chemical fingerprints in the expanding debris, astronomers can piece together the identity of the star that died. The evidence points to a red supergiant, a massive star that had already puffed off its outer layers before the final collapse. Perhaps this pre-explosion mass loss created a local shroud of gas and dust, hiding the star's final moments from our view. Cassiopeia remains a beautiful, expanding ghost, a stellar tombstone for a star that vanished without a proper farewell, challenging our historical records and our understanding of how the most massive stars end their lives. Death can be beautiful, and the Red Rectangle Nebula is proof. Far from the chaotic wreckage of a supernova, this cosmic object presents a spectacle of startling symmetry, a glowing red hourglass framed by what appears to be a perfect, if slightly rounded, rectangular structure. Located about 2,300 light-years away in the constellation Monoceros, this is not a place where planets form, but where a star has gracefully and mysteriously begun to die. At its heart lies not one star, but two, locked in a close orbital dance. As one of these aging stars exhausted its nuclear fuel, it swelled into a red giant and began to gently puff its outer layers into space. Normally, this process creates a classic spherical shell, a simple, glowing bubble of gas. The red rectangle is anything but simple. Its iconic shape is defined by two bright, opposing conical beams, forming a distinct X pattern that is neatly contained within the faint, rectangular outline of slower-moving gas. This precise geometry is the central puzzle. How does a dying star produce such sharp, angular architecture in the chaos of space? The leading theory points directly to the central binary system. Astronomers believe a thick, dense torus, a donut-shaped ring of dust and gas, surrounds the two stars. As the dying star expels its material, this torus acts like a cosmic nozzle, funneling the outflow into two powerful jets that shoot out from the star's poles. Because the entire system is spinning, these jets do not fire in straight lines but precess Wobbling like a slowing top, this procession sweeps the jets out, painting the conical shapes we see, and the surrounding gas is constrained by the torus to form the larger rectangular envelope. It is a celestial spinning top spraying luminous paint into the void, but the mysteries do not end with its shape. The nebula's deep, crimson glow is another enigma. Its intense red color does not come from the usual suspect, hydrogen, but from a strange class of carbon-based molecules known as polycyclic aromatic hydrocarbons, or PAHs. These are complex organic molecules, essentially tiny flakes of soot, that fluoresce with a distinctive red light when bathed in the ultraviolet radiation from the central stars. The red rectangle is one of the brightest known sources of these PAH emissions in the sky. The profound question is how such complex carbon molecules, the very building blocks of life, can form in such abundance and stability in the harsh environment around a dying star. This nebula is not just a pretty picture, it is a cosmic factory for organic chemistry, and we are still learning the recipes it uses. The red rectangle stands as a stunning example of how the final acts of stellar life can be orchestrated into breathtaking works of art, a geometric ghost glowing with the embers of complex chemistry, a temporary monument to the ordered beauty hidden within cosmic death. The ordered geometry of the red rectangle gives way to a ghost tugging at the edges of our own galaxy. Astronomers call it Galaxy X, a hypothetical dark satellite whose presence is felt only through its gravitational whispers. This is not a galaxy of stars and light, but a phantom, a collection of matter so dominated by dark matter that it emits almost no visible radiation to betray its position. The primary evidence for this unseen companion comes from the subtle warping of hydrogen gas clouds at the very fringe of the Milky Way's disk. These vast reservoirs of atomic gas are not moving as they should if only the gravity of our known stars and dark matter halo were influencing them. Instead, they ripple and flow as if being gently stirred by the passage of a massive, invisible object orbiting our home. It is like watching leaves on a pond swirl in the wake of a boat you cannot see. The hunt for Galaxy X is a direct test of our most successful model of the universe, the lambda cold dark matter model. This framework not only describes the roles of dark energy and dark matter, but also makes a very specific prediction about galaxy formation. It suggests that large galaxies like our Milky Way should be surrounded by a swarm of hundreds, even thousands, of smaller dark matter clumps and dwarf galaxies. These are the leftover building blocks from the cosmic construction process, yet, when we look around us, we find only a few dozen of these small, luminous satellites. This is known as the missing satellites problem. Where are all the rest? The answer proposed by theorists is that most of these clumps never gathered enough normal matter to ignite a significant population of stars. They are the dark galaxies, the silent, invisible majority predicted by our models. Galaxy X could be the most massive and significant of these dark satellites, a shadowy twin to the Milky Way, forever hidden in plain sight. The challenge of confirming its existence is immense. How do you find an object that does not glow? Astronomers must rely on indirect methods, searching for the faintest gravitational effects on the sparse populations of old stars in the galactic halo, or looking for the telltale ripples it might create in the stellar streams that wrap around our galaxy. Finding Galaxy X would be a monumental validation of our cosmological theories, proving that the dark matter scaffolding of the universe is structured exactly as we have long suspected. Its continued illusion, however, keeps one of the most profound questions in modern cosmology alive, forcing us to wonder if our galactic neighborhood is far more crowded with invisible giants than we ever dared to dream. This sharp edge of our solar system presents a puzzle as stark as the void itself. Far beyond the orbit of Neptune, in the frigid darkness of the Kuiper belt, astronomers have mapped a cosmic shoreline where the debris of our planetary system simply ends. This is the Kuiper Cliff, an unexpected and dramatic drop in the number of icy objects at a distance of about 50 astronomical units from the Sun. Imagine our solar system's outer suburbs ending not with a gradual fade into empty lots, but with a sheer precipice overlooking an abyss. Standard models of the solar system's formation predicted a very different scene. They told us that the primordial disk of dust and ice that birthed the planets should have thinned out slowly and smoothly, with smaller objects continuing for hundreds of astronomical units. Instead, our telescopes reveal a bustling community of icy worlds that suddenly and inexplicably vanishes. It is as if a cosmic gardener came through and neatly trimmed the edge of this vast celestial garden. What could have sculpted such a clean, abrupt edge in this wilderness of space? The most tantalizing theory points to the gravitational hand of a hidden giant. The hypothetical planet 9, a world perhaps 10 times the mass of Earth, is suspected to be orbiting hundreds of astronomical units away. Its immense gravity, the theory goes, could have shepherded the orbits of the most distant Kuiper belt objects, either flinging them inward toward the Sun or hurling them out into interstellar space, leaving behind this empty zone a gravitational footprint in the ice. This would make the Kuiper Cliff not a natural border, but the sign of a distant, unseen sentinel. Another possibility is that we are seeing a fossil, a preserved edge from the solar system's very birth. Perhaps the protoplanetary disk from which all the planets formed simply had a sharp edge itself, cut off by the gravitational influence of a passing star in our Sun's infancy, or limited by the size of the collapsing cloud that formed it. In this scenario, the Kuiper Cliff is a cosmic artifact, a snapshot of the precise conditions that existed over 4.5 billion years ago. Each theory carries profound implications. A hidden planet 9 rewrites our solar system's family portrait, adding a major world we never knew was there. A primordial sharp edge, however, forces us to reconsider the very nursery where our planets were born. This invisible boundary in the deep freeze remains one of the most compelling clues in the ongoing detective story of our own cosmic neighborhood, a silent question mark hanging in the dark. Just when we think we understand a star's final death rattle, the cosmos delivers a supernova that refuses to die. Known as IPTF-14 HLS, this stellar explosion was discovered in 2014 and initially appeared to be a perfectly normal, if somewhat slow, supernova. But as astronomers watched, its behavior became increasingly bizarre. Instead of fading away over the course of 100 days like any respectable supernova, it lingered, brightening and dimming erratically for over 600 days. It was a star that exploded, then seemed to change its mind and explode again and again, earning it the chilling nickname, the Zombie Star. The plot thickened dramatically when researchers examined historical photographic plates of that same patch of sky. They found evidence that an identical explosion had occurred in the exact same location in 1954. This star had apparently survived a cataclysmic supernova 60 years earlier, only to explode once more in nearly the same fashion. This is fundamentally impossible in our standard stellar models. A core collapse supernova is a star's final, irreversible act, the dramatic death of a single massive object. A star cannot simply reassemble itself and die again a few decades later, so what cosmic engine could possibly power such a resurrection? One radical theory points to an event of almost unimaginable scale, a pair instability supernova. This occurs in stars of immense size, perhaps over 100 times the mass of our Sun. In their cores, the heat and pressure become so extreme that light itself begins to create matter, spontaneously generating pairs of electrons and positrons. This process robs the core of its outward pressure, causing the star to collapse violently and trigger a runaway thermonuclear explosion that utterly obliterates it, leaving no black hole or neutron star behind. In this scenario, IPTF-14 HLS could have been the explosive death throes of the most massive star ever observed, with its multiple bright peaks representing successive waves of shockwaves rippling through its ejected material. Yet, even this Titanic model struggles to fully explain the longevity and the sheer energy output of this event. Another compelling idea involves a magnetar engine. Perhaps the initial collapse did form a neutron star, but one with a magnetic field of incomprehensible strength, a magnetar. The decaying, insanely powerful magnetic field of this newborn object could have acted like a continuous power source, pumping enormous energy into the expanding debris shell for years, causing it to re-brighten long after the initial explosion should have faded. Think of it as a stellar ghost, a cosmic generator left behind in the wreckage, refusing to let the light go out. Each of these theories pushes the boundaries of stellar physics to its absolute limit, and neither provides a perfect fit. IPTF-14 HLS remains a singular event, a cosmic outlier that challenges our most fundamental ideas about how stars live and, more importantly, how they die. It stands as a stark reminder that for every rule we write about the universe, there is a zombie star waiting in the dark to break it. While the zombie star defied death, another cosmic phantom challenges our very definition of a galaxy. Drifting in the heart of the Coma Cluster, a dense gathering of galaxies, lies Dragonfly 44. From a distance, it looks almost like a faint, wispy cloud, an apparition of cosmic dust. But this ghost holds a terrifying secret. Measurements of the speeds of its few remaining stars reveal a gravitational grip of unimaginable strength, a pull that demands the presence of a colossal amount of mass. The numbers are staggering. Dragonfly 44 has roughly the same mass as our entire Milky Way galaxy, a system of hundreds of billions of stars. Yet, when you look at it, you see less than 1% of the stars. This means that 99.99% of its substance, the very thing holding it together, is the invisible ghost we call dark matter. It is a galaxy built almost entirely from an enigma, a cosmic skeleton with barely any flesh. This discovery shatters the conventional model of galaxy formation. We always assumed that a huge halo of dark matter was necessary to gather the gas that would eventually form stars, creating the brilliant cities of light we see across the universe. Dragonfly 44 turns that idea on its head. It has the dark matter halo of a giant, but for some reason, the star formation process almost completely failed. It gathered the gravitational potential for a Milky Way, but only managed to light a few faint candles in the dark. Why did this happen? Astronomers suspect its location is the key. The Coma Cluster is a violent, crowded metropolis of galaxies filled with hot, stripping gas. Perhaps as Dragonfly 44 moved through this environment long ago, its own star-forming gas was ripped away, leaving the dark matter halo intact but starved of the fuel needed to shine. This makes it a fossil, a preserved relic of a failed galaxy, showing us that dark matter and visible matter do not always walk hand in hand. The implications reach far beyond this single, shadowy object. Dragonfly 44 is a flagship example of a new class of objects known as ultra-diffuse galaxies. These are cosmic ghosts, large, sprawling systems that are so faint they blend into the background of the night sky. For every brilliant spiral like Andromeda, there could be dozens, even hundreds of these dark dragons flying under our radar. Finding them forces us to ask a profound question about the nature of dark matter itself. Could certain properties of dark matter particles, perhaps the way they interact with each other or with normal matter, naturally lead to the creation of these vast, dark structures? Or are we simply seeing the full, predicted population of dark matter halos, most of which failed to light up? The hunt is now on for more of these phantoms, each one a vital clue in our quest to understand the invisible architecture of the cosmos. Sometimes the most profound clues arrive not as whispers, but as high-energy bullets fired from the depths of space. We have detected a stream of cosmic rays, specifically an unexpected flood of high-energy positrons, that strikes a discordant note in our understanding of physics. Positrons are the antimatter counterparts to electrons, and while they are naturally produced by known cosmic objects, there is a persistent, puzzling excess of them at energies where our models predict they should be dwindling. It is as if a hidden particle accelerator of unimaginable power is secretly at work in our galaxy. This anomaly has forced physicists to consider explanations that border on science fiction, including the mind-bending possibility of an entirely new state of matter, one so strange it has been dubbed unparticle physics. The concept of unparticles is a radical departure from everything we know. In our standard model, the universe is built from distinct, quantized particles like electrons and quarks, each with specific properties and masses. Unparticles, as proposed by the physicist Howard Georgi, would not behave like discrete particles at all. Instead, they would manifest as a continuous, scale-invariant substance without a definite mass. Interacting with unparticle stuff would not be like bouncing one billiard ball off another, but more like pushing your hand through a strange, energetic fluid that resists you in a way that defies simple description. If such a substance exists, it could be the source of these anomalous positrons produced in interactions that our current physics cannot yet model. The idea is that this unparticle field could cause normal particles to decay or transform in unusual ways, generating the excess positrons we observe. While this is a thrilling theoretical playground, the mainstream scientific community heavily favors more conventional cosmic powerhouses. The leading candidate remains pulsars, the rapidly spinning, intensely magnetic corpses of dead stars. These celestial dynamos can accelerate particles to near light speed, creating winds that collide and produce electron-positron pairs in abundant numbers. Several nearby pulsars are perfectly positioned to be the culprits behind the data, gathered by instruments like the Alpha Magnetic Spectrometer on the International Space Station. The challenge is that the pulsar models and the unparticle models can both be tuned, for now, to roughly fit the observed data. We are left at the very cutting edge of physics, where a concrete anomaly meets speculative theory. The path forward requires more precise data, perhaps from a next-generation cosmic ray observatory, that could distinguish the subtle signature of a pulsar's outflow from the potentially revolutionary fingerprint of something entirely new. This cosmic ray riddle embodies the essence of scientific discovery, a choice between the known universe working in an unexpected way or the first glimpse of a reality far stranger than we ever imagined. The hunt for the source of those mysterious positrons may have an answer, and it is a ghostly one. Just 500 light-years away, a dead star spins in the silence. This is the Geminga pulsar, the corpse of a massive star that exploded over 300,000 years ago. It is a powerful, ticking metronome, rotating 4 times every second and blasting out intense winds of charged particles. For decades, it was a prime suspect in the case of the anomalous positrons, a nearby cosmic engine that could easily be flooding our neighborhood with antimatter. But when astronomers turned our most sensitive gamma-ray telescopes toward it, they saw something that defied all expectations. Surrounding the Geminga pulsar is a colossal, perfectly spherical halo of ultra-high energy light. These are tera-electron-volt gamma rays, photons carrying trillions of times more energy than visible light. This TV halo is immense, stretching across dozens of light years, a ghostly orb of radiation that completely dwarfs the pulsar itself. This is the heart of the mystery. According to our established models of pulsar wind nebulae, this should not be happening. The powerful winds from a pulsar like Geminga should accelerate particles to fantastic speeds, but those particles should be confined to a much smaller region by the pulsar's magnetic field and the pressure of the surrounding interstellar medium. We should see a compact, bright cloud, not a faint, gargantuan sphere. The existence of this vast halo means that our understanding of how these cosmic accelerators work is fundamentally incomplete. Somehow, incredibly energetic particles are escaping the pulsar's immediate vicinity and diffusing outward into the galaxy at a rate far faster than our physics can explain. They are then interacting with the tenuous gas and light of interstellar space, creating this telltale glow of gamma rays. This discovery turns Geminga from a mere suspect into a local laboratory for the most extreme physics. It suggests that aged, nearby pulsars like this one could be responsible for a significant fraction of the high-energy particles, including positrons, that we detect raining down on Earth. The halo acts like a signpost, proving that these dead stars are indeed leaking energetic antimatter into the galaxy on a grand scale, yet the very size of the halo remains a profound puzzle. What physical process is allowing these particles to travel so far and so fast? Is there a flaw in our model of particle diffusion through the turbulent magnetic fields of our galaxy, or are we seeing the signature of a new, unknown type of interaction between pulsar winds and the void? Geminga's silent, radiant halo is a beautiful and frustrating clue, a local phenomenon that forces us to rewrite the rules for particle accelerators operating all across the cosmos. The universe's grand design may hold a subtle, unsettling flaw. Hidden within the oldest light we can see, the cosmic microwave background, is a pattern so controversial it has been given a dramatic name, the axis of evil. This is not a malevolent force, but a mysterious and unexpected alignment in the faint afterglow of the Big Bang itself. This primordial glow is the foundation of modern cosmology, a nearly uniform tapestry of microwave radiation that fills the entire sky, a snapshot of the infant universe when it was just 380,000 years old. According to our most cherished principles, this background should be isotropic, meaning it should look statistically the same in every direction, with tiny fluctuations in temperature that are randomly scattered like cosmic confetti. But when scientists create a map of these temperature variations, they find something deeply puzzling. The hot and cold spots are not completely random. On the largest scales, they appear to align along a particular plane in space, an axis that seems to have a specific orientation relative to the plane of our own solar system. It is as if the universe has a subtle preferred direction, a cosmic grain that should not exist. This discovery strikes at the heart of the cosmological principle, the fundamental assumption that the universe is homogeneous and isotropic on large scales. This principle is the bedrock of Einstein's theory of general relativity and our entire standard model of cosmology. Without it, our understanding of the universe's expansion, its composition, and its very origin would be thrown into question. The axis of evil suggests that on the grandest of scales, the universe might not be the same in all directions after all. We might be living in a universe with a faint but real cosmic architecture, a fundamental lopsidedness written into its first light. The debate over this anomaly is fierce and unresolved. Skeptics argue it is simply a statistical fluke. When you analyze a massive, complex dataset like the cosmic microwave background, you are bound to find some patterns that look significant purely by chance. They compare it to seeing a face in the clouds, a pattern our brains impose on randomness. Others contend it is an artifact of foreground contamination. Our view of the pristine cosmic microwave background is filtered through the bustling activity of our own Milky Way galaxy. Emissions from interstellar dust and gas could be creating a faint, structured haze that contaminates the signal, tricking us into seeing an alignment that is not truly part of the primordial universe. Yet, after years of analysis and new data from powerful satellites, the peculiar alignment has stubbornly persisted. If it is real, the implications are staggering. It could be a clue to something that happened before the Big Bang, a fossil from an era we cannot directly observe. Perhaps our universe inherited this preferred direction from a larger multiverse, or maybe the laws of physics themselves vary slightly across the cosmos. This single, subtle axis in the sky challenges us to consider that our universe's infancy was far more complex and possibly far stranger than our simplest models allow. It is a ghost in the machine of creation, a whisper that the cosmos may have a hidden spin after all. From the subtle drift of our own spacecraft to the incomprehensible voids between galaxies, these 25 cosmic puzzles reveal a universe that thrives on mystery. We have charted phantom galaxies built from shadow and watched stars die more than once. We have felt the pull of invisible giants and listened for signals in a profound and endless silence. Each anomaly, whether a fleeting radio scream or a permanent hexagon on a gas giant, is a testament to a cosmos far stranger, far more wondrous than our everyday assumptions allow. These are not the failures of science, but its very lifeblood. Every unexplained wobble, every impossible light, every gravitational whisper is a question waiting for an answer, a frontier calling out for the next generation of explorers. They remind us that our current understanding is not a final map, but a rough sketch, constantly being redrawn by new discoveries. So the next time you find yourself under a clear night sky, look up. Let your eyes trace the familiar constellations, but know that between and beyond them lies a reality of breathtaking depth and mystery. Let that feeling of wonder take root. Stay curious, keep questioning, and share the cosmic anomaly that captures your imagination the most in the comments below. Tell us which of these universes' secrets you would most want to solve, and let's continue this journey of discovery together.